This is section 3.3, part 2. Last time we did example 3. We left off with example 3, graphing the solution of a system of linear inequalities. We're going to do example 4. Going to do it the same way as we did example 3. We have to graph this inequality and we have to graph this one. So let's look at the top one right here. You notice, remember y equals mx plus b, where this is the b, this is the y-intercept. You're going to, on the y-axis, put a point at 1. The m is 3, or 3 over 1, so that means from this point right here, you're going to go up 3. 1, 2, 3, and go to the right 1. Now, whether or not you have a solid or dotted line depends on whether or not you have a line underneath this, whether it's less than or just less than or equal to. And since there's no line, that means our line has to be dotted. Now you have to shade. We're going to pick the test point 0, 0. Since our line does not go through the point 0, 0, we are allowed to choose that point, and 0 is the easiest number to plug in. So I'm going to pick the test point 0, 0, so I'm going to replace my y value with 0, and my x value also with 0. And simplify the left side, simplify the right. 3 times 0 is 0. Is 0 smaller than 1? This is yes, this is true. 0 is smaller than 1. Since that was true and our test point is here, we have to shade on the same side as the test point. We have to cover up that test point with shading. Now remember, when you shade, you're going to shade lightly with a pencil because you will have to erase. All right, now let's take a look at our second inequality. So we're going to put a point at -2 on the y-axis, which I don't know if you can see that, but it's right here. Okay, and the slope is -1, or -1 over +1 is our slope. So from this point right here, we're going to go down 1 to the right 1, which puts me here. And this is greater than or equal to, which means draw a solid line. Again, we're going to choose 0, 0 as our test point. So we're going to plug 0, 0 in, 0 for y, 0 for x, and check to see whether or not it's true. -0 is just 0. Simplify the left side and the right side. 0 subtract 2 is -2. And the question is 0 greater than or equal to -2. Again, that's yes. Since it's yes, we're going to shade covering up this test point. Remember to shade lightly because you will have to erase some of it. Now, as far as the answer goes, you are going to shade darkly then, where you have both colors or an overlap of the shading, and that would be right here. And then you erase anything that's a single color or that you only shaded once. So I'm going to erase this and erase this red up here. There you go. All right, so that would be the solution to that inequality, a system of inequalities. 5 you're going to do on your own. Let's take a look at 6 you're going to do on your own. Let's take a look at example 7. These equations or inequalities are in standard form. Easiest way to graph in standard form is use the XY chart. So for the top equation, we're going to plug in 0 for x. So I have 2 times 0 plus 5y. And when you plug numbers in, you're going to use equal. When I say plug numbers in, I mean when you're trying to find a point, you're going to use equal. 2 times 0 is 0. We don't need the 0. And divide by 5. You get y equals 2. You're going to plot that point. It's the point 0, 2, which is right here. All right. Now I'm going to plug in 0 for y this time. Okay, so plug in 0 for y. I have 2x plus 5 times 0 is equal to 10. Simplify the left side and the right side. 5 times 0 is 0. We don't need the 0. I have 2x is equal to 10. Divide by 2, and you get x is equal to 5. So the point 5, 0 is right here. I'm going to draw this as a dotted line. Notice there's not a line underneath that less than symbol. It's just less than, not less than or equal to. Test point again, I'm going to choose 0, 0. You always choose 0, 0 unless the line goes through the point 0, 0. So now I have to check for the shading. So now I'm going to plug in 0 for x, and I'm going to plug in 0 for y, and I'm going to leave this as an inequality. Okay, so when you do the test point, you have to leave it as an inequality. 2 times 0 is 0. 0 plus 0. The question is 0 smaller than 10? It is, so I'm going to shade covering my test point. So that's one of my inequalities. Now I have to do the other one. I'm going to do it the exact same way. Both equations are in standard form. So another xy chart. For the bottom one this time, I'm going to plug in 0 for x. So I have 2 times 0 minus 4y equals 12. 2 times 0 I don't need. Negative 4y is equal to 12. Divide by negative 4, and you get y is equal to negative 3. I'm going to plot that point right here. I need 2 points in order to graph a line, so I am going to plug in 0 for y this time. So I have 2x minus 4 times 0 is equal to 12. I don't need the 0, so 2x is equal to 12. Divide by 2, and I get x is equal to 6. Since it does say equal to, I am going to draw that as a solid line. Again, I'm going to choose 0, 0 as a test point. And this time I have to leave it as an inequality, not equals. Greater than or equal to 12. 2 times 0 is 0. Negative 4 times 0 is 0. And we have 0 is greater than or equal to 12. Well, is 0 bigger than 12? No, this is not true. This is false. So my test point is here, but it was false, so I have to shade on the other side of my line from my test point. And erase what was not double shaded. And that would be right here. Erase my line. There you go. So that is the answer to that system of linear inequalities. Let's take a look at example 11. Here we go. Y is greater than or equal to negative 3. Notice all I have is a y. I don't have an x and a y. That means it's either going to be a horizontal or vertical line, just depends. Since my y-axis goes like this, then y equals is going to go like this. It's going to be horizontal. So my y equals is going to be horizontal. So it says y is greater than or equal to negative 3. So I'm going to draw it as a horizontal, solid line at y equal negative 3. So now I have to do a test point. Again, I'm going to pick 0, 0. I don't have an x value to plug in, but I can plug in y. So is 0 greater than or equal to negative 3? And yes, it is. So I'm going to shade covering up the test point. Now, my other one, x is less than 2. My x-axis goes this way, so my x equals has to be perpendicular to it. So x is less than 2 is going to be a dotted line at 2. It's going to be vertical. Test point is 0, 0. Is 0 smaller than 2? And yes, it is. So I'm going to shade covering up. Now you can shade down here, but I already know that since there's no shading there already, that I'm going to have to erase it. So when I do it, I actually don't bother shading down here because I already know I'm going to have to erase it. And erase anywhere there's not double shading. There you go. All right, let's take a look at example 12. This has 4 inequalities. It doesn't matter how many you have. You just keep on graphing, you keep on shading and erasing. So erase as you go, shade as you go. Don't try and do this all at once, all the shading at once. I'm going to come back to this one. I'm going to start here. X is less than or equal to 2. That's going to be a solid vertical line. Do a test point, 0, 0. If you plug in 0, I have 0 is less than or equal to 2, which is true. So I'm going to shade covering up my test point. Now I'm going to have x is greater than or equal to negative 3. Again, it's going to be vertical and it is going to be solid. Test point, 0, 0. Is 0 bigger than negative 3? And it is. So I'm going to shade covering up the test point. Now, since I've drawn 2 lines, I'm going to erase anything that's not double shaded. And notice I didn't bother shading over here because I knew I was going to have to erase it anyway because there wasn't shading there already. All right, let's take a look at the bottom one. Y is greater than or equal to negative 1. That is going to be a horizontal line. And it is going to be solid. Test point is 0, 0. Is 0 greater than or equal to negative 1? Yes, it is. I'm going to shade covering that test point. And again, I didn't bother shading over here. I didn't bother shading over here because there wasn't shading already, so I didn't even bother. But there shouldn't be any shading down here now because that's not an overlap anymore because it has to be overlapped all 3 at this point. So where all 3 of the lines overlap. Okay. All right. Now I said I would come back to that first inequality. So let's do that one now. 5x plus y is less than or equal to 5. It is in standard form, so I'm going to use the xy chart, and I'm going to plug in x equals 0. 5 times 0 plus y. We don't need the 0. I get y is equal to 5, which is right there. I'm going to plug in y equals 0. I said that wrong. 5x plus 0 is equal to 5. 5x equals 5, or x is equal to 1. X is equal to 1 is right here. And that's equal to, less than or equal to, so I'm going to draw it as a solid line. Kind of crooked, but I am going to extend this green line because it does need to intersect, so I'm going to make that green line a little bit taller. And I'm going to choose 0, 0 again as my test point. Alright, so I got my test point right here. I'm going to choose 0, 0. Five times 0 is 0, plus 0. Is 0 smaller than 5? Yes, it is. So I'm going to shade covering up the test point. And this is why I extended that green line, because I knew I was going to have to shade up there. And erase any shading that now doesn't have 4 shadings here. I'll go back and redraw that red line. There you go. That would be the answer to this example 12.